Hi, everyone. Welcome to our workshop today. We're just going to have a little time just to let people start filtering in. We know people are ending meetings. My name is Nikki. I'm here from Commodore, along with Andre, who you'll be hearing a lot more from shortly. So nice to see everyone here as people are coming in. Luca, Matthias, Mikhail, Eric. Nice to see everyone. We're just going to give it a few more minutes, and then we will start off with Andre.
How's everyone? It's almost August, and I hope people are having plans for some vacations.
Oh, goodness. Summer vacation would be nice for everything right now. Rob and Sasha, Yuval, Shamsir. It's nice to see so many people coming through. We'll get going in just another minute. We're just letting people filter in.
I'll share my screen meanwhile to just be able to present, yes, like this. Can you see my screen?
Feel free to use the chat below. We'll definitely be taking a look at that throughout tonight's workshop or today's workshop, depending on where you are in the world. Feel free to use that. Also throughout Andre's talk, feel free to use that to ask any questions, make any comments. We'll answer that towards the end of the webinar. There's definitely a set time that Andre will be happy to answer lots of questions, but if something is really urgent comes up, we'll definitely answer that for you. Nice, there's so many people who came right away on time, so we appreciate. You can always tell who works in this space, shows up on time, likes things on time. So we definitely appreciate that. Well, I think we'll start getting things going just because I know that Andre's got a great presentation going. So welcome to Commodore's workshop. Tonight we're having our amazing open source dev leader, Andre, presenting hidden signals in Kubernetes clusters, a data-driven approach to reliability. Andre is a real star here at Commodore. He's able to give us some great insight with over 20 years of experience in the development space. He's an avid speaker on all things open source. You'll definitely do a Google on his name, you will find lots of great stuff. There's so much more that can be said about him, but I'll let you look for that yourself. So without any further delay, Andre, the controls are yours.
Thank you very much, Nikki. I welcome everyone. My name is Andre, and in Commodore, I'm doing open source initiatives like in most of my previous workplaces. And together with those open source initiatives, I'm doing some other projects for the company, but I'm always on the tech side. So in this talk, we had an idea to share some practitioner view of how we develop certain features so we can share the developer experience around Commodore projects in general. How do you make complex project a product from idea to the delivery into the product. If you have your questions, you can type them in or you can wait until the end. I will be addressing the questions at the very end of the presentation, so there will be no interruption to the flow of presentation. This is usually what I do when I present. Today's topics for us is the hidden signals in Kubernetes clusters and how can you get some interesting insights into reliability aspects of your Kubernetes clusters. The Kubernetes is the infrastructure layer, and the applications run using that infrastructure layer that creates own flow of events and information from that infrastructure layer. And those events, those data points, I call them signals sometimes, they carry the information about the infrastructure of your cluster, the infrastructure of your applications. But the challenge here is that the primitive statuses, events that Kubernetes exposes, they're not sufficient to drive deep conclusions, some deep ideas about what's going on over longer periods of times. So it requires additional effort if you want to get some bigger picture, like bird's eye view on your cluster over a month or a week of time. But it's kind of obvious if you're getting that information that you would like to analyze it. So if you take the idea of longer period of time, of correlation between different signals that carry the information about reliability of your applications, and if you take multi-cluster approach to that, all of that creates the urge to utilize the information. And you can think of multiple approaches of analyzing that information because the ecosystem has developed multiple approaches to that. You can analyze the timeline of how some signal evolves over time, and from there you can drive conclusions when it goes bad or when something happens. You can correlate multiple signals, multiple simple signals, one to another, and based on that correlation, find among multiple resources those who really live together and somehow interconnected. You can analyze into clusters the information that comes and drive conclusions of grouping in your services based on that. Or you can take the configuration information, which is kind of static. You can just fetch many YAMLs, but analyze those in a sophisticated way and also get some additional reliability issues or challenges resolved through there. In Commodore, we're actually in a very good position to analyze that kind of information. Why is because of the general setup of the Commodore, and here's the diagram that I extremely simplified for you. You install Commodore into cluster, and then the raw information starts to flow from the clusters into Commodore data ingestion pipeline, where we enrich that information. We create, this is important, synthetic events. So some of the information that we take and in the digestion pipeline, we create the synthetic events from it. So when it comes to the data that we store and process in Commodore, we're not only operating Kubernetes native, what we call Kubernetes native events, we also operate with synthetic events. And we also have some elements of monitoring. We are not fully blown observability tool with traces and metrics, but we have some of the most important metrics like CPU and memory. And that information gets stored and gets displayed through our Commodore platform. So we're having really good position to analyze and drive those conclusions from the Kubernetes information flow. So obviously, since we had that data, we had the idea of Reliability Insights project. What is reliability? Reliability is how good your application functions. Why insights is because from the raw information, you need to get some insights basically on what's going on. There's the lake of information, but what are the important points there? And we create a very simple setup to start investigate that information. We called it experimental setup. We took the Python script, connected a couple of data sources, and the output was going to the CLI. And from there, we started experimenting and coming up with ideas and validation of those ideas and what can be found there. So let's go through the examples of particular reliability insights, stopping at each one of them to understand what does it mean, why it's important for your cluster. The first example is container restart. There is the information about container restarts in Kubernetes, but you need to analyze it over prolonged periods of time to understand if your service experiences some disruption. And you also need to have some notion of disruption of a service. In Commodore, it's called reliability issue. So the reliability issue means that your pods do not come up in certain amount of time, that you're experiencing backoffs of some sort. So that is service disruption. And I've been in this position very recently. We are developing the AI-based investigator. This is the recent project I was working on. And I experienced that my boss was coming and saying, hey, I'm getting 502s all the time when I'm playing with your project. Please solve it. And the reliability insights already there in Commodore production. So I was curious, would it work for me? And I went there and I looked at this graph. You can see it on the screen. The graph shows that the density of container restarts was increasing and increasing over time. So something was wrong. The second step I took is I went to the monitoring, the memory usage graph of my containers. And immediately I saw that I'm at the limit of my memory all the time. And I had the obvious decision to increase the limit, and the 502s stopped since there. So this is very basic information. It's quite kind of obvious, but it involves grouping of container metrics because you can only monitor it based on containers. You need to group that information into pods, and from pods into deployment to have aggregate picture. And also thresholds can be subjective in different places of how many container restarts are bad for your case. Luckily, we have the configuration that allows you to tune the thresholds so it's meaningful for you. That is container restarts insight, and it's kind of timeline analysis, just calculation of density of events over timeline. Next thing is a bit more complex, is HPA maxed or CPU throttle insights. It's two separate kind of insights. When we are also analyzing a bit more complex multi-metrics formula over time, and here you see the screenshot of HPA at max insight triggered. When on the left you see one metric that is CPU-based HPA metric, and on the right its second metric is memory-based. You can see that CPU is not something that causes HPA to be constantly at the maximum level, and memory on the right is close enough and it's average, so it means that the maximums are bumping it up and causing it to be at maximum. So when HPA is at its maximum level for prolonged amount of time, it means that your performance is compromised. And what happens is that when you are hitting the CPU limits, there will be the CPU throttling, and your application definitely does not run at its full capacity, at its full capability, so you compromise the performance there. Second example is CPU throttled when individual container has not enough CPU, and it looks like this in our system when we track of how much of CPU throttle time you spend in given hour, minute. And you can see that this application was working basically either it's throttled or it's not throttled. It's very drastic picture. And again, the performance is compromised because 62% of the runtime, the CPU throttling happens. So you need to allocate more CPU in this case. But to actually figure out the CPU throttling problem, you need to collect that information over longer periods of time, analyze that, and then you get this kind of insight. It's again timeline analysis insight type. Another good example of insight, it's probably easiest to calculate that. You're basically just taking the information and you surfacing that. There's no complex formula calculation is involved, but it's very crucial for operations of the clusters. If you're just deploying your apps into the cluster and you do not administer the clusters, you do not maintain those, it's probably less relevant for you. But those who administrate the clusters, who operate the infrastructure, they know how much valuable is this. There is certain life cycle of Kubernetes, and what is worse is that each cloud provider has its own life cycle of Kubernetes flavors that they have or versions that they have. So something needs to be provider aware, lifecycle aware, and warn you a couple of months before the deprecation starts that it's about to happen, and preferably should analyze that some of your resources that live in that cluster would be affected by deprecations of the resource versions or removal of the resource versions. So it's a tricky misconfiguration or tricky configuration type of insight for us, where we do exactly that. We fetch the information from the clusters, analyze the type of the cloud provider, look at the end of life, look at the version deprecations for resources, and analyze and surface all of that information for you to be aware that you need to be upgrading your cluster, and if you are safe to upgrade, or you need to change the versions of resources before that, which may be a longer process of migrations on your application layer. That is very valuable, I should say, by the customer of ours, from what I heard speaking to the people. Now, the most sophisticated and difficult to spot without special machinery is the noisy neighbor. And the noisy neighbor is not something that we know in life when somebody's really noisy nearby. It's more about Kubernetes evicting pods. But the reason of that eviction is some workload, let's call workload A, that grows with its resource usage, and the reasons can be various. In most of the cases, it's just no limits on the resources of that workload. It starts to grow a lot in the node, and Kubernetes wants to satisfy the need of resources, starts to evict other pods of other workloads from the node. And if it happens on longer runs, on longer periods of time, you can see statistically that one of the service or some of the services are likely to cause these evictions to other victim services. And by that, because we have the notion of reliability issue, we can analyze it statistically and say that certain issues are happening because of the workload A getting out of control, basically. It's a tricky one to figure, and it's pretty valuable if you have larger infrastructure. Somebody all the time causes this noise and causes troubles to other services. And usually when you look at your service that restarts, it's not the one to blame. You should know that it's somebody else that is involved there. But in these insights that we just discussed, not all of them, not like these one were that we found usable, but there are some insights that are not really surviving the practice, the application, but I really enjoyed developing those. So I will be also showing you now something that didn't get into production, but it was really interesting. Maybe we will get it to production sometime after, when we find solution to those problems that were reasons to not include those. But it's at least worth mentioning what we've seen there in the research phase. So first interesting type of the insight is the idle workloads. It's actually really simple one, but easy to forget. It's waste of resources when you have pods and workloads that nobody knows what they do, and they do not do anything most of the time. They could rather be jobs as opposed to the pods. They have near zero CPU consumption. It's basically opposite of Throttle CPU. And the only reason why we didn't include those into our reliability insights is that it's questionable. Still, we see patterns when in some companies you do not consume CPU most of the time, but it's really critical for those services to be there and function, and nobody knows how to properly remove those. But it's valuable if you have a chance to analyze this aspect in your infrastructure, do so. To me, it was showing very interesting observations on our clusters. We found some of the pods that could be removed safely and save the resources by that. Another type of the insights is the outdated Helm charts. And we have a pretty good open source project, very successful one called Helm Dashboard. And there we have automated check for the existing new versions of Helm charts. And I know that people like that. I know that people value this feature, ability to keep up with the upgrades of your charts. And we experimented if we can include that functionality into reliability insights and report you on a weekly basis the digest of which of your charts can be upgraded. We hit some challenges. It puts quite a lot of pressure on your infrastructure if we just do it in an automated fashion on the background. It's unable to recognize properly if you have private repositories or local Helm charts. The open source project resolves that by being local and not in the cloud. And through the cloud, it's more difficult. But it's a very, very valuable piece of information that we saw. Maybe it will return to the product in some time because we know that people like that, people want that. Another interesting and very practical type of the insight that we observed, and we had this idea that a lot of people use spot instances and node auto-scaling in the cloud providers. And these nodes that are getting up and down all the time, they can also cause the pod restarts, evictions, and disruptions to the service because of that, the resulting reliability issues. So we started to implement the sophisticated correlation analysis of node termination synthetic events that we had in our system versus reliability issues. And it was very interesting to see that statistically, not everything is clear there. If we take very active clusters with the spot instance usage, you would see that there is consistent correlation between some of the reliability issues like backoffs and pods not getting up in time and those spot instances going down and terminating. As a result of it, we also had the pod termination statistics, so we knew we could show the statistic of which workloads were affected the most by the spot instance terminations and pod node terminations. It didn't make it to the final product, although it's not fully removed, it's just disabled there until we find a solution. It's pretty expensive to calculate, so we're thinking of how do we enable that. But we know that some of our customers would love that because they want to know how the spot instance usage affects their reliability. And finally, my personal favorite, this is something that I enjoyed the most when I was developing this insight, is the grouped failures, is the analysis of historical patterns of when something fails together. So if workloads fail in a quick succession and we observe prolonged periods of time, we can accumulate historical patterns and we can tell that some services live their life as dependencies, as factual dependencies. And cool thing is that what I saw in our clusters, that some of the services that I didn't know that are connected by the fact, they were in fact connected. They were always failing together. If you have service A failing, in 3 minutes you would have service B failing because of some unexpected shared caches through the intermediary services, etc., etc. So I used dbscan over timeline algorithm, which was a separate pleasure to develop that. And also it had double pass when on the first pass I was investigating current patterns, and on the second pass I was querying the historical patterns and then doing aggregation over aggregation. That was real fun to me to calculate. As you can imagine, it was very expensive to calculate this type of information, and dbscan is a pretty heavy algorithm to calculate the clusters over timeline. What was the most strong reason to not include it into the product is that it's very hard to explain, so what do you do with that information? It's really cool type of information, but how do you act on it? So we didn't include that because in Commodore, we usually, when we say there is a problem, we try to always say what is the suggestion to remove the problem or at least to mitigate the problem. And here it was questionable of what to suggest. The services live together. Okay, they are related. That's fine. But again, it was real pleasure to work on that, although it didn't make to the final product. So these were the what I call cool insights in this project. Now, as I promised, since I'm a practitioner, I'm talking more about the developer's life, what does it mean to develop these features? How did we go from the lab research to the ready product? Roughly, it was like this. We were starting, if you remember, from experiment setup, where we just had data sources, a Python script implementing the algorithm, CLI output, and you just quickly experiment and you understand, does it produce the information, the insights that we want? Next phase was, what is important on this stage? On this stage, it is important that you have ideas that you can quickly apply, quickly validate, and adapt your experimentation setup to that. And second most important thing I would say is the freedom. There was no real pressure for us. There was no restriction on the project initially. So we had real freedom to experiment, apply different approaches. And that is very important if you want to innovate, that if you want to create something really new and cool, and don't be limited in your thinking while you're doing so. Then we ran into second phase, that was internal review by Commodore colleagues. We had to complicate the setup a bit. Now we already had the scheduled runner, something that was running on a daily basis, and we had multiple insights, multiple Python classes of the code, and results, we were storing those into another PostgreSDB, and we were displaying that with no-code AppSmith, well, it's actually low-code AppSmith UI. So instead of spending a lot of time creating fancy React applications like we do for production solutions in Commodore, we used a very cheap approach that saved us a lot of time, and we were presenting that information to the interested parties. That was, again, as a developer pleasure, that phase, because we had to optimize a lot of SQL queries along the way. We had to add DB indexes, and it's very pleasant activity because you see very drastic results. You optimize the query and it becomes 10 times faster. You add the index and it becomes 100 times faster. Really pleasant experience. And then what we did is we started to do the dog fooding rounds and review in internal environment of Commodore. So we took our own production cluster and we asked our engineers to open AppSmith UI, find the insights that relate to their project, to their application, and tell us if it's meaningful and if it helps them to resolve any issues. We did some of these rounds. We cleaned some of the stupid things that nobody knew about just because there was no analysis like that before. And we saw the value. And with some of these insights, like those cool insights that I showed above, people were saying like, so what? What do I do with it? Doesn't seem to be valuable. It looks like sometimes noise, sometimes difficult to judge what to do on it. And then after those successful dogfeeding rounds, we went to the production setup. In the production setup, we developed the multi-thread running of these insights, scheduled with retries in case of occasional failures of infrastructure, with priorities because you want to run one before another. The results started to go into SQS queues for display in Commodore. And what is important to mention is that in the very beginning of the project, we were considering deploying something like Argo workflows or Apache Airflow, or at least Kubernetes jobs to run these insights. But finally, we settled with our own solution. So we didn't use anything third party for that because it was simple enough. Our needs are not as massive to utilize some separate to complicate our infrastructure, and we needed some very specific features from the runner process that it should be able to retry and do the ad hoc analysis for some of the live things. So we didn't use anything third party. We used our own home written project. It was another interesting task to develop that simple yet functional solution. And this is our story of developing reliability insights. What we have learned today, let's summarize that part. The basic Kubernetes information, the stream of data that flows there, hides that advanced analytics, and it is challenging. It's resource intensive. You need to store that data. You need to accumulate that. You need to develop this analysis. But the results are sometimes just cool, and a lot of times they are useful, and you can really improve your reliability. I should say that in the beginning, after deploying that in our Commodore production environment, we had a lot of insights popping up and saying, this is bad and this is bad. Now, when I'm going there, it's almost cleaned up because our engineers are also willing to keep reliability on the high level for their clusters. So we have implemented that. There is this dedicated area of reliability insights inside the Commodore platform. With that, I'll probably go and just show you everything that I'm describing right now. This is the Commodore platform in front of us. So this is how it looks. What we do is usually we divide in Commodore Kubernetes operations into three main areas. And those main areas are reliability, cost, and policies. We are interested right now with reliability area. So let's go. These are the basic metrics, CPU, memory, disk, numbers of pods, etc. The reliability is what we discussed today. So you can see in your cluster that the score is, there is some formula to score the reliability of the cluster. For example, you can see that there is a cluster that is approaching end of life, something that I described you how we calculated. You can see that there are some removed APIs that you can look into down to the level of individual resources. You can see that there is something you should do to be safe to upgrade. Right now, it's not safe to upgrade this cluster. Another good example would be the noisy neighbor. something that statistically shows that there is this service that pushes others out all the time. So somebody needs to talk to that service to make it maybe have stricter limits to not cause other services disruption. And then there's the large platform where we can start investigating the troubles of the services, the metrics that exist there, go into cost optimizations, many areas of the Commodore platform. If you are interested, you can contact us and we will give you a dedicated demo on that. There is this reliability area where you can consume these reliability insights, something that I was showing to you. The screenshots were made from this live system right here. A couple of clusters end of life, etc. So that is, I think, my final slide. Yes, thank you. And now I'm ready to accept the questions and have a discussion. Let me open Q&A tab.
Amazing. So Andrea, we've got a few things that were sent to us. So one of them was, what are the best practices for leveraging the vast amounts of data generated by Kubernetes clusters to gain actionable insights?
This is something that I've been describing. You would need to spin up these sophisticated algorithms and analysis. You need a tool for that, because what surprised personally me when I was first getting into Kubernetes is that it's very basic, it's very low level. It all speaks just YAMLs. You can query those YAMLs and that's it. You need some tool that would be doing something bigger out of it. So you need a tool. Basically, the answer is you need the tool. I see the Q&A question. Does the dashboard shown is open source, which we can try from our end? Depends on what you're asking. There is the Helm dashboard that is open source, and you can just Google Helm dashboard by Commodore, and you would find it. It's an open source project. There is the corresponding part inside Commodore product that will be addressing those Helm dashboard needs inside the bigger platform. The insights that I was showing, it's not open source, so it relies on the fact that you need to store the data. And this is what we had in Commodore in our main platform. So you can implement your own if you want. I described you basically ideas and approaches roughly. Or you could try Commodore Platform, because there is, as far as I know, the trial that you can just use. In a couple of weeks, you would be trying to your clusters. If needed, you foresee in field of Kubernetes cluster management and reliability, how should organizations prepare for these advancements? Of course, the trends in Kubernetes, of course, there will be these AI-related trends. So everyone will be doing this or that on the AI level, but that's probably not the most interesting. There are some obvious trends that are happening. Most of them will be related to scale. Since more and more organizations migrate into Kubernetes area, it's already like 95% of organizations say that they run Kubernetes somewhere at some scale. So there will be the massive scale. The fleet management will become the mainstream thing, because everyone would be having tens of clusters. Today, we see that only the bigger companies have tens or hundreds clusters. That will be the majority of the cases in the future. So individual cluster level will not go away, but there will be the need for the solutions in the massive scale in the fleet management aspect. So, for example, this is why, for example, Commodore is multi-cluster in its nature, because we understand the trend and we will be creating specific things that address cases when you have thousands of clusters. We have some of our customers who literally say, my plan is to have 2,000 clusters. How do you help me? So we'll have to address that, and the market will have to address that. Do you have any more questions? Let me see.
Yeah, don't be shy. Send us in those questions.
Yeah. Type anything, even if it's just the feedback, which is valuable for us. Mikhail, does your platform provide recommendations on tuning container resources in complex cases? For example, big difference in RAM requests limits may end with node evicting such pod, but that is not obvious, not easy to detect. Yes, that is, there is, so it will be two parts, twofold answer to that question. There is a special reliability insight that addresses exactly that. And it's called under provisioned workloads. It detects when the request, or maybe I'm confusing the name, but there is a special insight for that. When the ratio between limits and requests is wrong, it's risky. And we spot those and recommends and fixing that. And there is also the right sizing area in Commodore where you can go. Basically, let me show you. The best thing is to just show. You can go into cost optimization phase. This is the area. This is where this question belongs to. And there will be the right sizing advisor for you, where you can see that some of the services can save a good amount of money and resources because they're factual. This is very simple. You need to collect metrics for longer period of time, then you will know of how much does your application need. For example, this application uses a lot of memory, but barely uses any CPU. So you can limit your CPU and decrease it. Well, in this particular example, when we see to 0, it's a demo cluster which does nothing. And the idle workload insight would say just kill these services. We will not kill those services. They just idle because they are demo environment. In the real environment, you would see something different, like here, at least 12 millicores for this resource would be spent. So yes, we analyze that. You can see that there's some life in this service, and it's quite optimal already. It doesn't request a lot of resources, but probably memory limit should be set here, and we know exactly how much. I hope that answers your question. Let me see more. Shamshir, what are your thoughts on GenAI Assistant insights for SRE activities? Did you say you're working on that at Commodore at the moment? Oh, yeah. Yes, I am involved in that. Commodore is coming up with something in that area. I'm not allowed to announce that just yet by our marketing. But yes, the trend on the market is that to democratize Kubernetes. The problem is that many people don't know about Kubernetes and how to start working with it, and they are forced to do so by the organization. They need something that would help them. Some assistant or copilot that would be taking them by the hand and doing something with them for them. And many players on the market, I know that many players on the market come up with their solutions, and Commodore also comes up with its solution. And I've been working on that with my colleagues, and I am satisfied with the results. It's a pleasure to see that this unique technology, it's strange, you're applying language model to the pretty deterministic or semi-deterministic area, and it still works. It really does smart, suggests smart things on problems of reliability of the cluster. That's very cool. Stay tuned. I think somewhere, maybe in a month from now, we will have big announcement of what we have there, how it works. Right now, it's still almost finished, almost cooked, but we need to polish some of the rough edges there. Stay tuned, stay tuned. I'm not allowed. It's all marketing people who don't allow me to speak about it. But thanks for the question. You hit the right spot with it. Okay. Cool. Yes. Anything else I can answer? Any more questions that we have, or we just wrap up? If you like this type of content, give us feedback on it. Subscribe to our media channels to see more. I promise it's not the last appearance by me in our marketing channels. I will always speak about these kind of more techie things, practitioner things, because I like them. This is my role. So it was a pleasure talking to you as always, and thank you for attending this webinar.
So thank you, everyone. You'll be receiving a copy of this as well as Andre's slide deck. We're going to take a break next month from our workshop series, but we'll be back in September. And maybe along the lines with some of the questions that were asked will be exactly what we're presenting on. So look out for that. It will definitely be in our monthly newsletter that comes out. Make sure to subscribe. You can do that from our webpage. But have a great night. Have a great summer. And we'll see you soon. Have a great one.
Bye.